Hello and welcome. We're excited to have you join us. Today, we're going to talk about the Gemini model and open source software in action, and how you can connect generative AI models to the outside world. I'm Julia Wiesinger, a product manager in Google Cloud AI.
And I'm Chris Overholt, a developer relations engineer in Google Cloud.
We'll start with a brief overview of some of the new functionalities related to generative AI on Google Cloud. We'll focus on the latest news related to the Gemini model and where we are in terms of efficient and scalable multimodal generative models. The Gen AI world has transformed the way that we work in the last year. It's moving incredibly quickly, with new advancements happening almost daily. It's incredibly exciting to work in this space and to think about the many things that we can bring to life for our users, our customers, and our developers to make their lives easier as they integrate this technology into their systems. As many of you know from our continued announcements throughout the last year and our most recent announcements at Google Cloud Next, we've been very focused on our newest family of models known as Gemini. Gemini 1.5 Pro is a mid-sized multimodal model with breakthrough long context understanding. It features a new architecture that provides more efficient training and serving, an expanded context window of up to 1 million tokens for complex reasoning across vast amounts of information. The Gemini model also has better understanding across many modalities, including text, code, image, audio, and video. You'll also find exciting new features in Gemini 1.5 Pro, like parallel function calling and constrained decoding. Parallel function calling lets you call multiple functions in parallel and access information from multiple data sources rather than calling functions serially one by one. And constrained decoding is a technique that allows you to force a specific function call for a given prompt or conversation turn. That being said, generative models have limitations and non-deterministic responses that can make it difficult to integrate them into a broader application ecosystem. Have you ever received a non-answer about outdated information from a generative model? It can be incredibly frustrating, and this is a common problem with large language models. They are trained on a massive corpus of data, but the model itself isn't aware of new information and events that have occurred since it was trained. As a result, LLMs can sometimes give inaccurate or outdated answers. In this example, we might have asked an LLM to give us an exchange rate between different currencies, but the model responds that it doesn't have the latest information and that you should refer to an external source. Have you ever tried to get consistent outputs from a generative AI model? As you start to interact with these models, you might begin to see a lot of variation in the output, not just in the content itself, but also in the formatting and structure of the output. Even with exhaustive prompting, LLMs can produce inconsistent outputs, which makes it difficult to handle and parse the output downstream in your application code. In this example, we might ask the generative model to generate JSON output for customer records. And in response, the model might get triple backticks, invalid JSON, or fields with incorrect types or content. In the best case scenario, you'll get a reasonable success rate for parsable JSON, and sometimes variation of output. And in the worst case scenario, you might get unparsable content with mismatched types or mixed formatting. Have you ever tried to reference an external website, video, or API in a prompt to a generative AI model? If so, you've also likely encountered the response that the model is not able to access external websites, documents, or videos. This happens because generative AI models do not have an inherent ability to access external content that they aren't already trained on. In other words, they lack the ability to access real-time information or interact with external systems. This is actually for a good reason, since developers, users, and customers want to be sure that the model will only reach out to external systems if and when we need them to. In summary, generative AI models have some limitations that can make it challenging to integrate them into the broader application ecosystem. One challenge is that they often produce inconsistent output, formatting, and data structures, even with comprehensive prompting. Another limitation is that LLMs are frozen in time, meaning they lack access to new information outside of the scope of their training data. And finally, LLMs are disconnected from the world. This limits their ability to take action on behalf of the user and through common interfaces like REST APIs or databases. When you run into limitations with generative models, what workarounds have you tried? Prompt tuning, few-shot prompting, multiple chained LLM calls are common approaches to these problems. Let's talk about some of these common methods and techniques that developers use to overcome these limitations. You might have tried manually parsing responses to extract clean JSON data, pleading with the model to generate consistent outputs, or passing web links in the prompts. You might have also tried giving the model more specific instructions, grounding the model by implementing retrieval augmented generation, or giving the model additional context or constraints. Unfortunately, most or all of these workarounds often fail to provide a satisfactory or sustainable solution at the level of quality that you need. They can be time-consuming, error-prone, and may not generalize well to new scenarios. What we actually need is a better solution that allows us to connect generative models to the outside world in a structured and reliable way. This is where function calling, a native capability in the Gemini model, comes in. So what exactly is function calling? Does it call functions for you? What kind of functions can you use? Let's walk through the core concept of function calling, how it fits into the Gemini model and API, and what problem it actually solves. Function calling as a built-in feature of the Gemini API helps you transform natural language into structured data and back again. This means there is nothing that you need to add on or install separately. It's just there, ready for you to use it. When you work with function calling in the Gemini API, instead of getting back a natural language summary, we get back a structured JSON object. And when we complete the API call and return the output to the data in the Gemini model, we actually get a natural language response. In other words, function calling allows the Gemini model to return structured data responses, which we can then use to call external systems and APIs. This is quite different from the unstructured natural language summaries that we're used to getting back from generative AI models. Structured data is so much more easy to work with, especially if we want to use that information to call external systems and APIs. Now, let's go step by step to see how function calling works as a native part of the Gemini model. The first step in function calling is to define the functions you want to use. Think of it like creating a toolbox of functions that the Gemini model can choose from when we give it a prompt. Each function has a name, description, and parameters, which specify the type of data it expects. Once you've defined your functions, you need to wrap them in a tool. A tool is like a wrapper that can hold one or more declared functions. In the third and final step, it's time to call the Gemini model. When you make a model call, you can pass a tool argument that specifies the tool that you want the model to use. This tells the Gemini models which function it should consider when selecting the best tool for your given prompt. Now let's take that same step-by-step process and walk through a typical function calling scenario. First, an end user sends a prompt to your application that's powered by the Gemini model. It then analyzes the prompt and selects the most accurate function and parameters based on the tools you've provided. Once the Gemini model has selected the function and parameters, our application can make an API call to an external system. This could be a REST API, a database query, or any other type of API call that your system supports. Finally, the Gemini model returns a response to the end user based on the information that it has learned from one or more of the function calls along the way. To make this a little bit more specific, in the example of the life cycle of a function call, you can see how this process would play out if we were to design an agent that can interact with BigQuery and turn natural language inputs into SQL queries that we can make directly to a database. A useful way to think about this overall process is to put yourself in the shoes of an end user who's sending a prompt in natural language on one side of the system. And on the other side, the function calling capabilities in the Gemini model are translating those prompts into structured data objects that we can use to interact with external systems and APIs like we would in a traditional application. Next up, Chris is going to walk you through the developer journey of how function calling can be used in Gemini, connecting it to services like document repositories, databases, and other systems.
That was great. Thanks for walking us through all of the details and context around function calling, Julia. And now that you have a solid understanding of how function calling works and what problems it's trying to solve, let's talk about all of the ways that developers and customers have been actually using this functionality. So, what is it exactly that you can build with function calling? We've been working with lots and lots of developers and customers, and they've told us that function calling gives them the flexibility to create a wide range of applications, from extracting parameters out of unstructured text to more complex workflows that perform autonomous or agent-like tasks. Let's talk through different types of tasks that we would normally build with lots of custom logic and glue code just to make everything work. So on one side of this spectrum, function calling can handle simple tasks like fetching weather updates or calculating distances between points of interest. Or you might want to process thousands of unstructured documents and insert them as rows in a structured database. On the other side of the spectrum, you can use function calling for more complex tasks like searching through massive document repositories or performing real-time queries on databases, or even fetching information live from external systems while you're supporting customers. In general, function calling can be used to automate complex processes that really wouldn't have been possible using traditional business logic. And now that you understand the range of tasks that function calling can be used with, here's some of the most common use cases that we see developers applying it to. We've seen developers use function calling to build out internal search tools so employees can retrieve real-time information from databases and content management systems. Employees then use these tools to quickly get answers to questions across departments using live data from the systems they work with every day. Function calling also makes it easy to fetch real-time information from external APIs, like real-time financial data, travel information, or systems that track inventory and product lifecycle management. Function calling helps both human agents and virtual agents handle customer support cases more effectively by giving them instant access to relevant information without having to read through a bunch of documents or knowledge base answers one by one. Now, let's dive into some real-world examples and demo apps that show how function calling in the Gemini model can be used to build out very capable applications based on some of the use cases that we just talked about. So, can you use function calling to do retrieval augmented generation or RAG? Absolutely. Function calling is a multi-purpose tool that you can use for a wide range of tasks, and one of those is RAG implementations. So when you use a RAG approach, as a reminder, you retrieve documents based on an input prompt, you include them as context to the generative model, and then you generate a summary or an answer in natural language based on the raw contents of those documents. And the best part is, well, you can definitely use function calling to work with embeddings and retrieve documents from vector databases. You're not at all limited to working with just those types of systems. In fact, you can call out to any system, database, or document repository that has a REST API interface. So you can think of function calling as the most flexible way to implement RAG apps on almost any type of data source. Can you use function calling to talk to Google Drive and Google Sheets? Yes, you can. Function calling lets you interact with various external systems like Google Drive and Google Sheets, And this opens up a whole world of possibilities to build applications that can use data from these popular tools that we depend on for our day-to-day work. For example, let's walk through this application. It helps employees in an accounting department parse through and process hundreds of invoices. This particular application helps us work with hundreds of documents by using function calling to group them by industry, summarize the contents of the invoices, and then based on how we want to mark a particular invoice as paid or overdue or billable, it'll then upload the invoice to a particular folder in Google Drive and update a row in a Google Sheet that we can follow up on later. And in this app, all of the backend reasoning and API calls are powered by the Gemini model and function calling, so the app can perform very complex tasks and actually take action along the way. Can you use function calling to talk to SQL databases like BigQuery or Cloud SQL? Yes, you can. Function calling gives us a powerful way to connect to SQL databases and translate natural language inputs into runnable SQL queries. This lets you build applications that can access or modify data stored in databases and data warehouses. For example, you could create an app that generates summaries based on data from a customer database or real-time information from inventory systems. So all of these are just a few different examples of the many ways that you can use function calling to build out really powerful applications with generative AI. And you have the ability to execute custom functions that connect to external systems. So therefore, function calling is a really valuable tool for developers looking to leverage the full power of generative AI to build out complex automated workflows just like these. Now that you've seen how function calling works, let's look at some different ways that you can connect to the Gemini model to the outside world. We can actually add these layers on top of function calling to make our interactions with generative models more agent-like, more scalable, and more production-ready. When you need to add logic and error handling to your function calls, API calls, and function responses, you can use our LangChain templates on top of function calling. This really lets you turn the Python functions you already have into executable tools that the Gemini model can use to perform information retrieval or transactions via these API calls. When you need to add higher level orchestration to get agent-like behavior, you can implement your own custom logic with LangChain or Llama Index or any other framework to handle that function calling, API call, and function response loop. Function calling in the Gemini API doesn't replace or get in the way of how you want to implement orchestration in your own apps. You can actually use function calling in Gemini on their own with no additional frameworks, or you can bring your favorite framework. Choice is totally up to you. When you need to productionize and scale your agent for business critical applications, you can deploy all of your agent tools and orchestration layer on Vertex AI with a single command using an additional component we call Reasoning Engine. So Reasoning Engine gives you the scalability, security, and reliability you need to handle even the most demanding workloads. It's a really nice way to encapsulate your agent for other developers and other departments to build on top of your agent capabilities without them having to worry about managing prompts or chat history or orchestration frameworks. In fact, you can deploy and query a reasoning engine in Vertex AI using any of the available client libraries like Python, C#, Java, Go, and Node.js. Now, I want to show you a couple of options that you can use to jumpstart your own developer journey into function calling. You can use function calling as part of the Gemini API in Google AI Studio. AI Studio is a really nice place to get started with the Gemini API and function calling, since it gives you an interactive sandbox where you can try out everything that we talked about today. You can choose to work with the user interface in the AI Studio, or you can work directly with the Gemini API using the Python client or REST API commands. You can also use function calling via the Gemini API in Vertex AI. And this is really useful if you're looking to build out in enterprise-ready generative AI apps and you're already using or planning to use common services in Google Cloud like GCS, BigQuery, Vertex AI, Document AI, Google Workspace, and a whole bunch of others. Now, I want to point you to some of the best resources that you can use to start coding and go hands-on with the Gemini API when you're ready. You can try out the step-by-step code lab, and it will guide you through the process of interacting with function calling using the Vertex AI Python SDK. You can also try out an interactive notebook that walks through different ways of using function calling for use cases like parameter extraction or multi-turn chat sessions. You can also refer to the function calling documentation in Vertex AI to dig deeper into some of the concepts and code samples that we talked about today, and you can learn how to apply them to your own use cases. And finally, on behalf of me, Julia, and everyone on the Vertex AI team who made all of this amazing functionality possible, we want to say a big thank you so much for your time and for joining us in this session today. We really hope that you found the session useful and that you're excited as we are to get hands-on and start building with function calling in the Gemini model. We really can't wait to see the types of problems that you solve and the generative AI workflows that you build with it. And we hope that you enjoy the rest of your experience at Google I/O. Thanks.